we've learned about solving systems using substitution and graphing. We have one more method to talk about. So this is the first video in the elimination method. Elimination method. We learned to solve systems by graphing and using substitution, but we have one more method to learn. Elimination method is useful when answers are not clear on a graph or we don't have a variable isolated. The goal of the elimination method is to remove or eliminate one of the variables to create one equation with one variable. Same goal as substitution. To use the elimination method, all like terms need to be on the same side in their equation. For example, if the x is on the left side of the first equation, it must be on the left side of the second equation. When using the elimination method, we need to add the two equations to eliminate one of the variables. To do this, we need a variable with coefficients which are opposites. For example, 2y plus 3x equals 10, and 6y minus 3x equals 15. We have the coefficient of the x value opposite, 3x and negative 3x. So let's talk through an example. What do you notice about the locations of the variables? Well, both the x's and y's are on the left sides of the equation, so we can use elimination. Do any of the variables have a coefficient which are opposite? Yes, the coefficients of the x's are opposite, 2 and negative 2. Now what is occurring in step 2 when we add the equations? 2x plus negative 2x is 0x, 3y plus 5y is 8y, and 10 and 6 is 16. When we add the equations, the x values are eliminated, so there's only one variable in the equation. We're now down to one variable in one equation. So what occurred here in step 3? Well, we solved for y by canceling the coefficient. Y is 2. So where did the equation come from for step 4 now? Well, if we look back at our original equations, this comes from our original equation, 2x plus 3y equals 10. And so we're going to substitute our value in step 4. This is what occurred. We have substituted the value of y, which we solved for in step 3, and we're going to solve for x. We get x equals 2 as well. So what does the ordered pair represent? The ordered pair is a solution to the system and is a point which is true for all equations in the system. Let's look at some more examples. In the first example, we have 5y and negative 5y as opposite coefficients. So we're going to add our equations. The y's cancel out and we get 7x equals 21. So x is 3. Plugging x is 3 back into one of our two equations and solving for y, we get y is 3/5. So our point is 3/5. In the second one, we have 2a and negative 2a are going to cancel out when we add them. So the a's are gone and we get 2b equals 8. Divide by 2 and b is 4. Plug b back into one of our equations. 2a minus 3 times 4 equals 11. Multiply and we get 2a minus 12 is 11. Cancel the constant by adding 12. We get 2a equals 23. And dividing by 2, a is 23 halves. 23 halves, 4. And if you're wondering how I wrote the points, I always write them in alphabetical order, just like x, y. In the third example, well, we do have 5e and negative 5e are opposites, but they don't line up very well. So we're going to rewrite the equations to line the e's and the f's up. They're on the same side already. We want to rewrite them so that they're lined up. The e's cancel out and we get 7f is 28, so f is 4. Plug that back into our equation and solve for e. E is also 4. Or 5e is 4, and when we divide by 5, e is 4/5. So our final point is 4/5, 4. Now I know I went through these examples kind of quickly, so pause the video, look through the math, make sure you understand how it works. And then try these two. So in the first one, we're going to cancel the y's, and we get 8x equals 16, so x is 2. And plugging that back in, we get y is 7, so with our 0.27. In the second one, we're going to cancel the y's again, and we might have to rewrite them so the y's line up. So we have x minus 3y and negative 3x plus 3y. Cancel, and we get x is 6 and y is negative 7. So our point is 6, negative 7. Now that's it for today. Nice job. You made it to the end of the first part of elimination. We'll talk about what happens when we don't have it as easy with the coefficients when we come back in our next video. Have a great night.